Okay, so today we are going to be doing an optimization problem. So what we're going to be doing is, I've got this problem set up here. So we've got a rectangle, and we're going to be finding the minimum perimeter of this rectangle. So we've been given the area, right? So it's 120 centimeters squared. But we're going to be finding the perimeter of this rectangle with the different sections in it too. So y will have 4 parts. So it's a little bit different than the problems that we've been doing. But anyways, the first thing we need to do is set up an equation for the perimeter. So what we can do is we can do p equals 2x plus 4y, because that's what we've been given here in this drawing. So now that we have this equation here that relates to the perimeter, we're going to go back to the area. So we know that the area is 120. That's equal to x times y. But we need to get one of these variables by itself, so that way we can go back into the perimeter and figure out what the perimeter will be. So we're going to divide by x to get y. So we can have y equal to 120 over x. So therefore, anywhere that y is in the perimeter equation, we can input 120 over x. So let's go ahead and do that. So p equals 2x plus 4, 120 over x. So that's what we've got right now. Okay, so we can solve this. We can work with this. So now we've got p equals 2x plus, and then we're going to multiply 4 times 120 to get 480 over x. And then we're going to move this x to the top, just so it's a little bit easier to work with this problem. So that's what we get. We're going to get p equals 2x minus 480 x to the negative first. Alright, now that we've got this, we're going to take the derivative of that. So, we're going to get 2 minus 480x to the negative 2. And now we can't have that negative exponent up there, so we're going to move that back down to the bottom, just like so. Okay, so now we are going to butterfly. So p equals 2x squared minus 480 over x squared. Alright, now that we've got this, we are going to take this top part right here, and we're going to put it equal to 0. So 2x squared minus 480 equals 0, plus 480 plus 480. Just like that, just solving here. So x squared is equal to 240, and then x will be equal to the square root of 240, or about 15.492. Okay, so now we've got an x. So let's make a derivative sign chart here. So, just gonna set it up. Alright, so we know that that's equal to 0. So now we all know how to do a derivative sign chart. So we're going to input a number that's smaller than 15 into the derivative, and we're going to get a negative number here. So it's going to be decreasing. Okay, and then we're going to input a number larger than 15 into the derivative, and we get a positive number. So it's going up. So we know that this right here is a minimum when x is equal to the square root of 240. Okay, so we've got that. So now what we're going to do is we're going to go back up here to this equation we have, because we've got x now, so we can solve for y. So, the square root of 240y is equal to 120. We're going to divide by the square root of 240. And y is going to be about 7.746 when we input that into our calculator. So we're going to use that equation right there. And we're going to use our perimeter equation, right? So p is equal to 2 times, let's get the exact number here. So the exact number for the square root of 240 is 15.492 plus 4, and then what y is, 7.746. Alright, but we're going to use the actual equations here. So 2 times that right there, plus 4 times that number. So this is what we get for P. We get 61.970 about centimeters. Don't forget your, oh, don't forget that. And then we can get the dimensions from this. X being 15.492 and Y being 7.746. Alright, so we just found the minimum perimeter for this problem.